Welcome to G Fun Facts Online. The Arctic is a realm of stark beauty and brutal extremes. For millennia, its frozen landscapes have thawed into a brief, brilliant burst of life, a siren call to millions of birds from every corner of the globe. This ancient drama of migration, survival, and renewal is now being rewritten by a force of unprecedented speed: climate change. The Arctic is warming at least 3 to 4 times faster than the rest of the planet, and its avian inhabitants are on the front lines of this profound transformation. This is the story of their struggle, their remarkable adaptability, and the uncertain future they face. To understand how Arctic birds are coping, we first need to appreciate the extraordinary adaptations that allow them to live in one of the planet's most inhospitable environments. The primary challenge is, of course, the cold. To survive temperatures that can plummet to -40 degrees Celsius, these birds have evolved a suite of physiological marvels. The most obvious is their plumage. They possess an incredibly dense coat of feathers. An outer layer of interlocking contour feathers acts as a windproof and water-repellent shield, while a thick, fluffy underlayer of down traps a layer of air next to the skin. This trapped air, warmed by the bird's body, provides superb insulation. In fact, white feathers, common for camouflage, are structurally composed of air cells, which enhances their insulating properties even further. Beyond feathers, Arctic birds use sophisticated circulatory strategies. The most notable is the counter-current heat exchange system in their legs. Arteries carrying warm blood from the body run in close contact with veins carrying cold blood back from the feet. This allows the warm blood to transfer its heat to the cold blood, warming it before it re-enters the body and preventing a dangerous drop in core temperature. It's why you can see a duck standing on ice without freezing its feet. Metabolism also plays a crucial role. To generate heat, these birds maintain a high metabolic rate, an internal furnace fueled by significant fat reserves. The Svalbard rock ptarmigan, for example, can accumulate fat stores that account for up to 30% of its total body mass. These physiological traits are matched by ingenious behaviors. Simple actions like fluffing up feathers increase the insulating air layer. Many smaller birds like ptarmigan and redpolls burrow into the snow to escape the biting wind. Huddling together is another common tactic to share body heat. But the most dramatic behavioral adaptation is migration. The vast majority of Arctic birds are long-distance migrants. They undertake incredible journeys, often spanning continents, to exploit the brief but explosive productivity of the Arctic summer. The Arctic tern holds the record, traveling from the Arctic to the Antarctic and back each year, a journey of over 44,000 miles, to live in a world of perpetual summer. This strategy allows them to escape the harshest part of the year and raise their young in an environment with abundant food and, historically, fewer predators. But the finely tuned adaptations that have served Arctic birds so well are now being challenged by the chaotic changes sweeping the region. One of the most significant impacts is a shift in phenology, the timing of seasonal events. Snow is melting earlier, and the growing season is starting sooner, throwing the entire ecological calendar into disarray. Migratory birds, whose journeys are often initiated by cues like day length thousands of miles away, are in a race to keep up. Many species are showing remarkable flexibility. Studies on geese and swans show they are speeding up their spring migrations by reducing the duration of their stopover periods, where they rest and refuel. But this has a cost. Arriving faster might mean arriving in poorer physical condition, compromising their ability to breed successfully. Scientists estimate that, for some waterfowl, this strategy of faster migration may only be a viable way to keep pace with warming for another 18 to 28 years. Once on the breeding grounds, the race continues. Researchers in the Alaskan Arctic found that species like the semi-palmated sandpiper are advancing their nesting by an average of 4 to 7 days over just a 9-year period. But arriving and nesting earlier is only half the battle. The crucial question is whether their breeding coincides with the peak abundance of their food. a phenomenon known as trophic mismatch. The Arctic summer has a short, explosive pulse of insect life, the primary food for the chicks of many shorebirds. If the chicks hatch too late, after the insect peak has passed, they may struggle to find enough food, leading to reduced growth rates and lower survival. This temporal decoupling of predator and prey is a subtle but potentially devastating consequence of a warming climate. Climate change isn't just altering the timing of food, it's fundamentally restructuring the entire Arctic food web, especially in the ocean. The most profound changes are linked to the dramatic loss of sea ice. Sea ice is a critical habitat. Algae grows on its underside, forming the base of a food chain that supports zooplankton, which in turn feed fish like the Arctic cod. Arctic cod are energy-rich fish that are a cornerstone prey species for a multitude of seabirds. As the sea ice retreats, this entire system is being upended. Studies on Svalbard have shown a clear link between poor sea ice conditions and a decline in the colony sizes of black-legged kittiwakes and Brunich guillemot 2 years later. This 2-year lag reflects the life cycle of the Arctic cod. Poor ice leads to a poor year for young cod, and 2 years later, when those cod would have been the ideal size for seabirds to eat, they simply aren't there. Seabirds are being forced to switch to less nutritious prey. As warmer waters allow more southerly fish like capelin to move north, they are displacing the energy-dense Arctic cod. For birds like the thick-billed murre, this means switching from a high-fat diet to smaller, less nourishing options, which negatively affects their breeding success. For some, the connection is even more direct. The ivory gull is intimately tied to the frozen ocean, where it scavenges on the remains of seals killed by polar bears. With the decline of both sea ice and polar bear hunting success, the ivory gull has suffered a catastrophic population decline of 80 to 90% in just the last 2 decades. On land, a similar story is unfolding. The population cycles of lemmings, a key prey for predators like the snowy owl, are becoming erratic. Warmer winters are leading to more frequent thaw-freeze events, where melting snow soaks the ground and then freezes into a hard layer of ice, locking away the lemmings' food supply and causing their populations to crash. The very ground beneath the birds' feet is also changing. The thawing of permafrost is causing the tundra to slump and erode. It is also allowing shrubs and even forests to expand northward, a phenomenon known as SH rubification. Scientists predict that as much as 39 to 57% of tundra habitat could disappear by the end of the century. For the tundra bean goose, it's estimated that 76% of its current habitat will be affected, making it impossible for them to breed. Meanwhile, for coastal nesting birds, rising sea levels and increased storm surges made worse by the lack of protective sea ice are washing away nesting sites. Historically, the Arctic was a relatively safe haven for breeding birds. This is no longer the case. As sea ice disappears, polar bears are spending more time on land and are increasingly turning to alternative food sources, including the eggs and chicks of colonial seabirds. Simultaneously, predators from the south, like the red fox, are expanding their range northward. A global study found that the rate of predator attacks on Arctic shorebird nests has jumped from around 40% to as high as 70% in recent years. The once safe Arctic is now a riskier place to raise young than many temperate locations. A final, more invisible threat is the emergence of new diseases. As the Arctic warms, it becomes more hospitable to pathogens like novel strains of avian influenza and West Nile virus. Thawing permafrost also carries the risk of releasing ancient, dormant pathogens. For bird populations already stressed by changes in food and habitat, the arrival of new diseases could be devastating. Let's look at how these broad impacts are playing out for specific species. The Atlantic puffin, with its brilliantly colored bill, is a beloved seabird. Puffins hunt for small, energy-rich fish like herring and sand lance to feed their single chick. But climate change is making this hunt difficult. The Gulf of Maine, home to the only U.S. breeding colonies, is warming faster than 99% of the world's oceans. This is causing the puffin's traditional prey to become scarcer. In some years, puffins have been observed feeding their chicks butterfish, a more southerly species. The problem is that the puffin chicks, or pufflings, are unable to swallow these larger, rounder fish. Many have starved to death in their burrows, with a belly full of unsuitable food. In 2021, puffin colonies in Maine experienced a catastrophic breeding failure. Yet, in a sign of the ecosystem's complexity, the following year saw a rebound in breeding success due to an abundance of sand lance. This highlights that the impacts of climate change are not always linear and predictable. Next, the snowy owl, a true icon of the tundra. These nomadic predators are intricately linked to the population cycles of lemmings. As we discussed, warmer winters are disrupting lemming populations, making the food supply for snowy owls dangerously unpredictable. This is a major factor in the global snowy owl population decline, which has seen numbers drop by an alarming 64% since 1970. The physical landscape is also changing for them. Thawing permafrost is degrading the open, solid tundra they require for nesting, turning it into a landscape of mud and expanding pools of water. Finally, let's consider Arctic shorebirds, like sandpipers and plovers. Many of these species undertake some of the longest migrations in the animal kingdom, traveling from the tip of South America to the high Arctic. They make this arduous journey to breed in a land of plenty and safety. Now they find the Arctic is no longer the safe nursery it once was. As we've seen, nest predation has skyrocketed. Species like the critically endangered spoonbill sandpiper are facing immense pressure from this increased predation, which could be the final nail in their coffin. On top of that, they are at the sharp end of the trophic mismatch. They are advancing their nesting times, but their insect food sources are emerging even earlier, creating a dangerous gap between when chicks hatch and when their food is most abundant. The plight of Arctic birds is a global issue, and conservation requires a coordinated international effort. The Arctic Council's Conservation of Arctic Flora and Fauna Working Group runs the Arctic Migratory Birds Initiative, or MBI. This connects countries across the major flyways to address threats like habitat loss and unsustainable hunting. Monitoring is the bedrock of this work. Programs like the Arctic Shorebird Demographics Network involve intensive fieldwork across the vast Arctic, tracking population trends and reproductive success. This data is essential for identifying which species are in the most trouble. The information gathered informs concrete conservation actions. These can range from pushing for the protection of critical stopover habitats to highly specific interventions. On the Copeland Islands, for instance, a project used puffin decoys to successfully attract birds to a new, predator-free nesting site. In northern Sweden, a project is working to protect a vast mire landscape that is a crucial breeding ground for many waders, integrating traditional ecological knowledge from Sami reindeer herders with scientific research. The future for Arctic birds is fraught with uncertainty. Their proven resilience and the dedicated efforts of the global conservation community provide a glimmer of hope. But the scale and pace of climate change present a challenge of unprecedented magnitude. The adaptations that are working now, like faster migrations, are likely temporary fixes that will be outpaced by continued warming. The fate of Arctic birds is inextricably linked to our own. They are the sentinels, the canaries in the global coal mine. Their declining populations and their struggles for survival are a clear and urgent warning of the far-reaching consequences of a warming world. The arrhythmia in the ancient heartbeat of their migration is a symptom of a planet in distress. Protecting them isn't just about saving birds. It's about preserving the integrity of a vast and vital ecosystem, and, ultimately, about safeguarding a stable climate for all life on Earth. The final chapter in their story has yet to be written. Whether it is one of resilience and recovery, or one of loss and extinction, will depend on the actions we take today.